That was worth waiting for. So I'm in hyperspace. Okay, so hyphenation space is what we're going into this hour, and TeX82 is using brand new hyphenation algorithm, who I've noticed is in the audience here to correct me in case I make any terrible errors. This is going to be described in his thesis that comes out any day now. I guess it is, isn't that right? And I'm going to first explain to you the way it works, and then we'll play with it a little bit so that you get some idea about it. And then I'll show you how it fits in the TeX code. This, of course, is a special interest to people in foreign countries, so that they'll be able to use TeX with other languages. However, I have to mention that at present it will only support one language at a time, at least per paragraph. It would be rather difficult the way I described hyphenation, saying that the second pass would go through and hyphenate every word. But what if the word is, the paragraph is half in Hebrew and half in English or something? We only have one hyphenation tables that we're using all the same through. So there's other problems with that, of course, too, because there's left to right versus right to left. But we're going to assume that we're using only one language at a time anyway. And if somebody wants to extend it to switch between hyphenation tables and so on, well, that's a what's it node that could live there in the paragraph. When you pass the what's it, it could select hyphenation table such and such. Now, the hyphenation is based on idea of patterns, which is one thing that unifies many of the things in the ad hoc hyphenation algorithm that we used in the present version of TeX. If I have a pattern that's, for example, A, B, 2, D, and I put zeros on between it when there is no positive number. This would mean that if there was a word, if I'm trying to hyphenate a word that contains a subsequence A, B, and D, then I would try to insert a 0 before the A, a 0 between A and B, or 2 between B and D, and so on. And I do this for all patterns. I take the maximum of the numbers that apply. If the final result is odd, it's a place for hyphenation, and if it's even, it's a place where I don't hyphenate. So 0 is even, so I wouldn't hyphenate there. If I put a 1 in here, that would be a good, I suppose I put a 1 here, and that would say that's a good place to hyphenate. A, B, D, that would say put a 1 there, so hyphenate there. But then you look through all the patterns that you did with zeros and ones, and you got some bad cases. So then you can go and say, well, but let's suppress it if it fits in this pattern also, and the 2 will then knock out a 1 because it's even and higher than 1, and we're taking the maximum. And then if we still don't get enough hyphens that we want, then we can put 3s in there, and they'll override the 2s. And so this was the genesis of the idea. The neat thing is how well it works with the right pattern. So let's take a look at some examples. Now I guess first of all I could look at the patterns that generated on Sunday. So let's see. That's edit P5. Now this is page 1 of 3879. So there are 3,879 patterns in this particular list, and these patterns seem to work rather well for English. Now a dot stands for the beginning of the word. So the first pattern is beginning of the word A, C, E, and the 4 means between the 4 and between the C and the E. You would suppress very strongly. You probably never want a hyphen with a word that starts with A, C, and the next letter being E. The next one says if you got a word that starts with ach, you don't want to hyphenate there. and so on. Okay, these are the things. Let's take a look at line 2000. You get some of the. We're in the middle of it now. Here's a LP saying don't hyphenate before the pair LP. But here's a strong case for hyphenation, LPA-B. Okay, yeah, you can move to a seat where it's easier for you to see the monitor. LPA, if you got if a letter that has LPAB, I can't think of any right now. What would be the word for that? Then you want to break there with very strong 5. So odd numbers are for hyphens, even numbers not for hyphens. Okay, so that's what the patterns look like. And now if we see what actually this algorithm can do, we take a look at some sample files. There are several of these, and first let me show you the one that's called except hyphen. Let's see, that's IP. These are words that were exceptions to the present TeX hyphenation algorithm, I guess, and so they were put in here to see what would happen to them. So the asterisk means that we do find the hyphen. And wait a minute, my monitor isn't showing anything, is it? But yours are working. Oh, here it goes. Okay. Asterisk means we find the. No, this isn't. Yeah. This is just a bunch of exceptions. So, for example, if you try TeX right now, the one you're using now, it would say cell fadjoint, and this was in a collection of words that were a little bit hard to hyphenate. Asterisks show the hyphens that this new algorithm will find. And the hyphens are the ones that it didn't find. Didn't do well on this one. Let's try the next one. Those tended to be hard words. This next one, TeXcom. These are the words that were listed in the appendix of the TeX manual as being words that computer scientists were interested in, and what we wanted to pick up some of the hyphens. And so the asterisks here almost everywhere mean that we've picked up just about every hyphen on these words. So algorithm, computer gets hyphenated. Declaration, we missed the hyphen after the C there. Subroutine, say. Okay, so these words all got pretty well hyphenated. Now, if we want to look at the whole dictionary, and this is Webster's Pocket Dictionary. That was the dictionary that was largely the basis for these hyphenation patterns. And this one is 101 pages, so each page will give us a few words out of it. Okay, so we started out, and we found the hyphen in aardvark, but abakai we didn't get, and so on like this. Okay, so now you see that we pick up almost all of them here. Yeah?
You left the numbers on the left column. We can see it on the monitor because it's off the left edge of the monitor.
Oh. Let's see. What's going on?
We can't.
Oh, you can't see the. Uh-huh. Is there?
The last page with a lot of numbers on the side.
Because I can see it on my monitor up there, but does this do it? Does this screw it up? It's no good. Okay, well I don't want to mess with that. Okay, is there a hack in E that will move every line over? What? Control right arrow does what? Edit? Control. And that moves it over as much as it can? Okay. You do that again? Okay. Oh, our computers are wonderful. Okay. Now there. So okay, you see that in this case there's a lot of after AC with a T, then we it's a good place for a hyphen. But acuity, it wouldn't put a hyphen after an AC. Okay, well, let's get to some harder cases. Let's see what's going on here. Adaptations, adaptable, adage, I don't know. You see, sometimes you want a hyphen after 2D, after the second D, and sometimes not. Adding and so on. Okay, now the statistics are that actually the method has picked up 88.3 of the hyphens in this dictionary, and it made only 27 errors. Now, error means it put in a hyphen where there shouldn't have been one. Okay, so let's see if we can't find a place where there was an error. And a period shows in here as a place where reaffirm mode, read only. Okay, now I'll have to shift this over to the right again. What happened? It just did it from that point on. Okay. Okay. No. Well, that's okay. We don't care. I was only interested in this associate. So it put in a hyphen there on associate, and that was considered an error. Well, why is that? It's because apparently the dictionary lists that word twice, once with a hyphen and once without a hyphen. Okay? So that's not such a bad error. Associate is the noun, and associate is the verb. And according to the dictionary, in one case you would consider it to be a three-syllable word, in one case a four-syllable word. Okay, so if you really are upset about that, then we would put that into the hyphenation exception dictionary that TeX has. All right, so that's one of the 27 errors. And so you get an idea. So where should I look in this file? If people have some idea, some of the hard ones are where we start with DE or something like that. Let's take a look at that. Page difficult. Okay, around difficult. Let's see. First of all, I go to page 1. That's the directory to the whole file. Read only. Okay, so let's see. By the way, this gives you a fairly random look into the file, too, for words. We're hitting all of these pretty well. Difficult is going to appear in page 26. But let's take a look at some of these others to get an idea. Forger didn't get hyphenated there, but who would want it to come out forg anyway, you know? Genesis, we missed one of them. We don't really care, those that are 2 from the end, because TeX isn't going to hyphenate 2 letters away anyway. Okay, I said page 26 was where we could look for that. So page 26 is okay, I'm sorry, I'm supposed to move this over now. So ta-dum, pa-dum, pa-dum. Sorry, repeat substitute command is what? Oh, I forgot top. Okay. Ta-da, ta-da. See, so. Ta-da, ta-da, ta-da. There we go. Okay. Now, so remember the asterisks are the ones that get picked up. And you'll notice that it does pick up nicely the sometimes here DE hyphen S, in other places DES hyphen, depending on the context. And no errors are present in this particular part. Okay. Now these patterns were generated by a program that is written in web and is going to appear in thesis, and it'll be possible to get this program and run it for other languages, for other dictionaries. And you have different constraints in different kinds of text that you're setting, even if you're working with English language, so that you could use different dictionaries for those words. The patterns that says that the time to run the program was 57 CPU minutes on Sunday. It makes, it goes through lots and lots of calculations in order to find the good patterns for this purpose. The program is available to use. Okay, so now we still haven't gotten up to difficult, but we can see that when it does miss a hyphen, it tends to miss two of them in similar words, that they tend to go in clusters. Well, where's difficult? Let's go on and on. Detain, detect, deteriorate. We're picking up lots of these. Determinants, determinable. No wonder it didn't find that one. Okay. Well, see, I can't search for difficult because it has these other things in it. Maybe I could search for DIFF star, or DIFF period would be good enough. How about, what's tab mean? Oh, that means, yeah, okay, I got it. So, different, okay, we're close here now. Difficult, okay, and difficulty, but difficulties didn't see. Curious, okay. Now, if you look, so you look up above and below it, lots and lots of hyphens are in there. So indeed, this one uniform method for patterns is quite successful. Now let's try playing with it. I wanted to show you another set. That now we took another dictionary that we got from commercial firm for newspaper setting, and ran it through a previous set of patterns and looked at all the things that didn't work in that case, and then made sure that, and they were words that weren't in the pocket dictionary, weren't in Webster's pocket dictionary, but still were common. A lot of them are modern words, words that have gotten into the language recently, or more of some interest. We wanted to make sure that we didn't make errors on these words. For one reason or another, they weren't in the pocket dictionary. So. Well, Afghanistan, we don't seem to find any hyphens in. Oh, yeah, right. Okay. So there are some of these words that these were ones that caused trouble for patterns that were only based on the pocket dictionary, and then we had a much larger database of several 100,000 words. I don't remember exactly how many, but much larger one, which we could also check that we wouldn't make any errors. And I believe there's only one error in this whole file now, and I'll be able to find it in a minute. Notice cryptanalysis. This is one that was hyphenated wrong in my article in Scientific American. I remember that one. It came out cryptanalyze or something like that, Okay. Digitize. The ones that we're kind of interested in. Actually, this list of exceptions included some things like dumbhead that were kind of interesting, and a surprising number of obscene words. Okay, well, heuristic, sorry. Joystick, we didn't pick up the hyphen in this. Terrible. Okay, so now what I did was I wrote okay, read only. So I wrote a program called TeX hyphen, and as you can see, I can try executing TeX hyphen. Now this just excerpts the hyphenation part of TeX, and then it gives us a chance to type in words, and it'll show us how the hyphenation algorithm performs. So I'm compiling it now and loading it, and I have to input my test file, pat-dat, and it typed out, you can't read it, but it typed out, please wait. Now at this point it's computing from all those patterns, it's computing a very efficient data structure so that to do the hyphenation is going to be real fast. I'll explain the data structure in a few minutes. Okay, now it's ready, and it said the hyphenation table sizes are 5207 and 174. This 5207 is the number of words in a trie, T-R-I-E, that's in your TeX web listing. And this is a data structure we'll be talking about it. So it's 5,200 words to store all those patterns in a very efficient way, so that the hyphenation will really be quite fast for English words. And that's 4 bytes per word, so 20K bytes was used for 21K bytes essentially are in that table. 174 is the number of opcodes I use in another table where I'm limited to 255. And those are the so-called hyphenation ops in the listing. Okay, now we can type some text in here, and I'll type it over at the right so that you can see what I'm typing, I hope. But I'm not looking at an edited file now, so we're stuck with this problem of something being on the left. I guess what I can do is I can just put a bunch of nulls at the beginning of the word. So I'll type XXXX supercalifragilistic expialidocious and see what that hyphenates into. Okay, the X's came out on the left, so you can see the rest of it. Now, where this puts now in this there's a different notation. Here, a hyphen is something that the algorithm finds, and a double, an equal sign, is a place where it found an even number greater than 0. So where a hyphen was suppressed by one of the patterns. So where I had a 2 or a 4, I'd get an equal sign here. Where I get a 1, 3, or 5, I've got a hyphen. So if you look at supercalifra, it missed one hyphen between li and fra. Jill, I think it could have put one there. Anyway, it's certainly a valid subset of the legal hyphens, but at the end of the word, it didn't get very many. Now, this, of course, is a word not in the dictionary, but you see that we'll find words that are English-like, and it'll do pretty well on those words. I'm willing to take suggestions from the audience. Do you have any ideas? Okay, let's try a German word. Wissenschaften. Okay. Let's say Computerwissenschaften, so you get to see the Computerwissenschaften. It worked. Now somebody said record, and that it turned out was one of the errors in that other file. It found either record or record, one of the two. And the same thing for progress versus progress, and the same thing for one other case, present and present, right. So they've all now been added as exceptions in the hyphenation exception list, 7 of them altogether. And so if I type record now, it will just not do anything to it, because it's been an exception where I said, don't touch it, don't touch that word. The funny thing happened in the Palo Alto Times Tribune a couple of weeks ago, or a month or so ago, where there was a paragraph that had, it was 3 lines long, and on the first line it hyphenated record properly, R-E hyphen. And the second line it happened to end with record, R-E-C hyphen O-R-D. And on the third line there was a missed a completely wrong hyphenation. I forget what I saved the example. I'll make a slide out of it. But it must have been done by manual intervention. But then they let the automatic algorithm go on for the rest of the paragraph, and it blew it. Yeah. So right now I have 7 exceptions in the dictionary. So when we generate the patterns, then we look for the dots in the resulting file, and we decide whether those dots are real errors or not in our minds. Sometimes there's bugs in the dictionary, and the ones that we are upset about, like I could have put associate in there if I was upset about it, then make a dictionary for that. But this percentage, 88% found with a very compact table. It compares very favorably with any other method that was known to get an approximation for this. And what was the corresponding figures for the present TeX algorithm? Do you remember? We pick up about 40% now. I thought it was only in the 20s, but maybe, I guess you're right because we got so many prefixes in there. Respite. Respite got no hyphens. Must be in the Pocket Dictionary. See, there won't be any errors for any word that's in Pocket Dictionary, which is a pretty complete dictionary. Now, I think if I type \T here, it'll go through a database that came right out of the Pascal manual. I type in every word of 5 letters or more out of the Pascal manual, and well, I guess you can't read it now, but I'll tell. If Springer didn't get hyphenated, Verlag did, Heidelberg did. The hyphen before the G there isn't going to bother anybody because TeX doesn't use the hyphens at the very end of the word. Berlin came out okay, Pascal okay, Manuel okay, Report okay, Kathleen yes, Jensen no hyphens at all. Niklaus, that's fine, I think. No? No, okay. Well, then it wasn't. But to an American, it sounds fine, so it's based on English, so it must be okay. Preface. No, what I mean is our hyphenation patterns are supposed to work for English, you see. So, version, programming, language, drafted, followed, spirit, algol, languages, extensive, development, phase didn't get hyphenated, first didn't, that's good. Became operational, publication, followed, it's working. Interest, development, yep, it's all doing fine there. So a booklet consists, parts was not hyphenated, I'm glad to see. So all these things done it, okay. Let's start at the end. We got some more French word here. Pierre Desjardins, criticism, suggestions, encouragement, Helmut Sandmeyer, Switzerland. Okay. So that's the way this thing performs based on these patterns. And if you look at the details of the words, it really is something that has promise of working even better in languages other than English, which English is weirder in this respect, I think, than other languages are. So the success of this looks quite promising for just replacing this by another set of patterns. All the patterns are being put into basic TeX. So in other words, your format, when you start running TeX at all, it knows no patterns, and you have to input those as part of your format, and basic will input a separate file that contains the patterns on it. So that people have their own favorite files they can do it. Now, besides patterns that go in, patterns are read only by Initech, and it does a fairly elaborate computation to get the patterns into an efficient form. But then there's also the chance for users to put in their own exceptions, and that's done with hyphenation, And then here you list the words that you want to hyphenate, especially in case you noticed when we had a statistician picked up a word, there was some 20-letter word I'd never heard of before and surely wouldn't be in this dictionary, and it was hetero something or other, if this method doesn't do well on it, then you can certainly put this in. If you're curious about which patterns, which were the 7 exceptions, I guess I might as well flash those up on the screen. That's pat file. Oops. Okay. These were the words that were sufficiently strange that it was better to have them as exceptions than to make the patterns check for them, because that would knock out other good patterns. Oh, there's more than 7. Okay, let's see. That was control. So declination, obligatory, philanthropic, presence, progress, reciprocity, records, retribution, and rhetoric. In this file, I use this \h instead of hyphenation because this is a program that doesn't recognize control sequences except one letter once, just to give it like this \t at the bottom here is a toggle that switches back between online and stored in a stored dictionary of stuff. So the last pattern was ZZY. So if you said XYZZY, it would not hyphenate between the two Z's. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 words then were given as hyphen. So basic TeX will include these 7 exceptions, and the 3,000 some patterns. Any question on that? Okay, now let's see how they use these patterns to go real fast to do the hyphenation. This idea of a trie is a data structure that I discuss at some length in my book on sorting and searching, and another word for it is a digital search tree. But there's a special kind of a packed trie that developed that does the thing beautifully. And let's see if I find the thing in the. Let me find the algorithm for you in the manual. Hyphenation is section 41, and it starts in module 806, page 283. And so if you have a pattern, P1, P2, well, let's suppose I have a pattern ABC, because I used that, or ABD, I used that example before. So to find this pattern to see if there's anything in the tree for ABD, we could set Z1 to A, and then Z2 would be set to trilink, which I can just call L for brevity, tree link of Z1 plus B, and Z3 is L of Z2 plus C plus D, where these are the internal ASCII codes of the things. Z3 is now going to be the identification of the pattern. However, I have to have a check that this pattern is legitimate. Well, let me see. So then I also have a check that something is going. So what should I call that? Let me call it C. C of Z1 should equal A. C of Z2 should equal B, and C of Z3 should equal D. If any of these conditions fails, then there's no pattern in the dictionary. But if all three of these conditions are true, then Z3 is a number identifying the pattern ABD. So the trie is constructed in this fashion, and basically it's like this. At the beginning, you think of this as some long, say, 5,000 word array. And we start out and we look in position 97 of the array, and we put that number in Z1. No, we set Z1 to 97 and look at C of Z1 and see if there's an A in there. If so, then good. At least we have at least one pattern starting with A. Then we look at L of Z1, which tells us another starting place in the tree, and that's for all patterns starting with A, you see. And L of Z1 might be 15, say. So then we add B to 15, and we look here, and if there's a B stored there, then there's been a pattern starting with AB. And then we pick up L and that'll be Z2, and L of Z2, and add D to it, and we see if there's a D there. If so, then we've got an identification of that particular pattern. Now, what actually it turns out is that if you look at the tree and you see, well, first of all, you've got to reserve all the locations for the first letters in the tree. So suppose everything can occur the first letter, then we'd fill up 26 places here in this table. Then after A, maybe there's only 7 letters that fit. So we find a place where we can pack all 7 of these in here. And finally, we get to things that have only one valid successor, and so there's easy to stick them in and fill up all the holes and not waste any space. Now, you see, the idea is the method is extremely fast. We just have to check one thing and fetch, add, check, fetch, add, and we've identified whether the pattern occurred. And the actual code for this is, I think, module 810. Yeah, we've got our word stored in let's see, we've got our word, module 810. We've got our words stored in the HC array, and we set, let's see, here we go, HC array, and so we put delimiters before and after the word to mark the beginning and end of the word, and then for each place within the word, we try to look for a pattern starting there, and this loop is the look for a pattern in there. So Z is set to the HC of J, that's this like Z1 set to A, and L is set to J. This is our starting position. While HC of L is equal to trichar G, trichar is my C that I was talking about. Then I continue and I go ahead. As soon as I get to by the way, the pattern might be of various lengths. There might be a pattern of length 3 and also a pattern of length 4 starting at a given place. So I also look at Z1 and Z2 to see if there's a triop stored with it. A triop means that we have found a pattern there. And so in that case, then I would go through and store maximum values in the Hive table as I'm supposed to. Usually it'll be min quarter word, which means null. So then I increase L, and Z set to the next element plus HCL, and go through the loop again. So just a few instructions per iteration, and the loop almost always dies out very quickly. At the end, then, we have something that will contain odd numbers or even numbers, depending on whether we should put a hyphen in or not. Okay, the hyphenation exception table is kept in a hash table with a technique called ordered hashing. That's of a little interest too, but I won't go through it now. And first we look up in the exception table to see if we got a hyphen. If that fails, then we go through the pattern matching process like this. And in both cases, we're gonna finally store the patterns in this hyph thing, which will be either even or odd, depending on whether we want to want to hyphen there or not. Any questions on this? Okay. Now, there has to be a definition of what things in a paragraph we try to hyphenate. Well, hyphenation is shut off inside of a math formula, but we also want to be sure that we could try hyphenating words that are surrounded by quote marks or parentheses or something like that, followed by punctuation. We don't want that to interfere with our hyphenation process. And so TeX, on the second pass, does the following thing. It starts out a space, and then passes after the space until it gets to the first letter. So this could pass over quote marks and parens or things like that till it gets to a letter. And then, starting at that letter, if the letter is uppercase, it makes sure that that we're supposed to be hyphenating uppercase. It only looks at the first letter of the word. If the first letter is lowercase and the second letter is uppercase, we'll try hyphenating in any case. And for this purpose, the definition of a letter is not using the Checode to see whether the Checode type is 11. Or 12 for other char, but the definition of a letter is something that has a UC code value. That's the uppercase or the LC code. I forget one of the two. I think it's LC code, lowercase code, non-zero. If the character has LC code non-zero, then it's considered a letter. So standard thing is, for example, LC code of lowercase a is lowercase a. LC code of uppercase a is lowercase a. This is the way you convert uppercase to lowercase through the LC code table. And it's intended, of course, for large alphabets and other foreign alphabets so that we have idea as to what it means to convert to lowercase, because we convert everything to lowercase to look it up for hyphenation. And then afterwards, after we know the hyphenation patterns, then we put the hyphens, of course, in the original word, preserving the uppercase and lowercase the way they were. Yeah?
How do you tell if it's a capital?
If LC is not equal to itself, it's uppercase. It's considered uppercase. So that's, yeah. And then we go until we get to a non-letter. And then we go until we get to sort of a safe point. So a non-letter might be a period or a comma or a quotation mark or something. Then we go till we reach either a glue or penalty or something like that. Now, if we reach either before this word or after the word, if we reach a dangerous thing like a box, then we give up. So before the word and afterward, it's supposed to be innocuous stuff. So if there's a discretionary hyphen, it's considered dangerous. It means that the author has said how he wants this word hyphenated, so we don't touch that. So if we run into a discretionary hyphen anywhere in this process, we assume that we've been given already the correct information about this, and that shuts the whole process off. If we run into a box, that turns it off, and a couple other things would turn it off. A math formula, for example, would stop it, but penalty would say we're at the end of a word, penalty or glue. So those are so really we cover all the common cases of text. And there is another slight clarification has to be made. We're passing through ligatures here, as well as kerning little pieces of space that have been inserted into the word for typographic effects. And let's talk about those. Well, kerning we just ignore. We just bypass kerning and collect the word that would be there if the kerning wasn't there, and try to hyphenate it. Then we put the kerning back in again. Talk about how to put the kerning back in again also. Now, but ligatures, suppose you made a ligature out of a letter and a non-letter. So maybe somebody gave a ligature for left parenthesis C, something like that. Well, I'm sorry, I'm not going to worry about weird cases like this. So a ligature, if a letter is in the middle of a ligature, I don't start hyphenating there. I'll start hyphenating after it. And at the end, similarly, if there's a letter followed by a non-letter in the ligature, I will chop that letter off and not consider it part of the word being hyphenated. So what we actually have here is the word being hyphenated is given by nodes and not by parts of nodes. It's not the part of a ligature at the beginning or the end, but we definitely have a set of nodes in our horizontal list that's a word that we consider a candidate for hyphenate. This set of nodes, which consists of either character nodes, ligature nodes, or kern nodes, is the candidate. It expands into the candidate for hyphenation. And so it's not. We don't split a ligature between punctuation and letters. That would be weird to try to handle that. Okay. Now we got this word as a candidate for hyphenation, and if it has fewer than 5 letters, we don't bother with it. So we've got to have 5 letters or more. If so, then we look up in hyphenation table. If it's not there, we go through the patterns, even and odd business, and we wind up with a bunch of hyphens. Now I mentioned the other day about difficult and what we have to do after that point. Let me give you an even worse example. Now, I'm going to give you one that's so bad that we might not even get it right. But I think we'll get it right. And it's in the test program at the end of this document. Appendix A contains a test program, and this is, like I said the other day, it's a program that is not intended to do anything useful. It's intended to exercise the different parts of TeX. And have I discussed these appendices so far in this class, or was that in conversation outside of class? I don't remember. Have I talked about it yet at all? Oh, okay. I mentioned the other day, I mentioned that TripTech was supposed to be a little bit of a pun, but that's about all I did. Okay, so TRIP is this test program, starts in Appendix A here, and I haven't gotten all the way through it, but I believe that by the time I get all the way to the end of this program, and I'll probably change a little bit after I get all the way to the end, I believe there will be high probability that TeX is near its final bug. That all the ones after anyway will be extremely subtle or related to error recovery. However, I have not tested it yet so that I got all the way to the end, and in fact, you'll see that there's the word end sits somewhere in the middle of this file right now. It's just stopping it where it is. I think it's, oh wait, let me see. No, it's actually probably, oh, end is, yeah, right there. It says temporary ending on page 1-3, temporary ending. And that's just where I looked up hyphenation of a very strange word, B, 6 B's there. And I set, just here in this test program, I've set the uppercase hyphen to 1, which means I'm going to hyphenate uppercase letters. And I set H size to 100 point, line penalty to a large number. And so this is going to give me, on one line of a paragraph, something that it won't be able to do without breaking the tolerance, because this will have to stretch too much in order to do it. So it'll go into the second pass and try hyphenating this word B. And then it'll give me an underfull box message that will show me how many hyphens it found. So, and then I said end. That's as far as I got through testing this program. So you might just read the rest of it and try to guess what it's going to do, but you can't tell. Now the Appendix C shows the result of the test program so far. So when you install TeX at your system, you can at least try it on TripTech and see if it doesn't give you the same output as you see here in Appendix B. All of these files are on the tape that be distributed, so that you can compare with it. And at the very end of that, Appendix C will be what it did, this underfull box message that it gave us for the B, and it's here. on the bottom of page C9. The short version of it says we're in font 20, and it hyphenated BB hyphen B hyphen 3 Bs. And the long version of it, oh gosh, unfortunately it says etc. there. And so we don't get to see what the discretionary nodes are that were inserted for those hyphens. Well, that's a shame because they're rather beautiful, but we'll work out in class exactly what those would be, and in the final test program I'll have cut the box. I'll have made it so that part of the box would print. Now, why did BB get hyphenated that way? Well, the reason was I put that in as a hyphenation exception. So previously in that test program, it actually told it to hyphenate everywhere. I put in hyphenation, actually with lowercase b's, I put in B hyphen B everything. But I told you TeX takes back a hyphen in these positions, and so so the test program was at least working to the extent that it found all 6 hyphens in that algorithm, but it took them back. And if you really want to get a hyphen there, you could put it in as a discretionary yourself, but otherwise TeX hyphenation method won't do it. Now, what about this? There's a strange font in use here called the trip font. The trip font is something that doesn't exist on any printer, but it only exists as a TeX font metric file. And Appendix B shows this font and gives the ligature information about it. And this is an example of a PL file. We'll talk more about ligatures and things tomorrow, but basically, so let me just summarize for you. When a B is followed by a B, we convert it into an A. When a B is followed by a hyphen, so wait, let me write this down. BB goes into A. When a B is followed by a hyphen, it goes into a C. You realize that ligatures can also involve hyphens, and so when we're doing our discretionaries, that would also have to take account of that thing. And B followed by a C gets kerning. It goes into B kern C. Now A followed by a B has some kerning associated with it. And A followed by a hyphen is also kerning, but I think that'll affect A followed by a hyphen gets some kerning, and then in that font it turns out that A followed by A turns into A, but that isn't going to rise in this example. So now, anyway, this letter then, when I made up the paragraph for the word BB, what happened? Well, the BB turned into an A. So this was a ligature A. A followed by B inserted a kern node there. And then I had a B, another B. So it turned into A kern A kern A. And that was what was in the list when the paragrapher started to work on it. Then the second pass took over, and so we had to hyphenate this word. Well, we looked at this and the ligature remembered where it came from, and it came from 6Bs. So looked up the hyphenation table, found that there were hyphenation points here, and we see what we can do. So then, in order to insert the first hyphen, notice that we have to go back and figure out what the ligatures would be in both cases. So in the first case, where there's no hyphenation, we get an A followed by a kern, followed by something else. But in the case that the hyphen is present, we would get an A followed by a different kern by this hyphen. So we have to make up a discretionary node where the first case corresponds to if we're going to break here at this hyphen and insert the hyphen. In that case, we would put in, I believe, the ligature BB followed by a kern, followed by a hyphen. And in the other case, there would be nothing, I think, and in the BB followed by a kern in the case that there's no break taken. Remember, a discretionary has three parts. This is, if there's a break, this comes before break, this comes after the break, and if there's no break, we use this text. Now, the next case is more interesting or more complicated, depending on your point of view. And that is after you've decided whether or not to break at this hyphen, what about this hyphen? If you don't break at the hyphen, we see what's supposed to turn out into A, kern A, for those last four B's. But if we do break at the hyphen, the whole pattern is changing. Because these two B's are then going to combine into a ligature, and this B in the hyphen is going to be a ligature, so that the next part of it's going to make a discretionary. And if we take the hyphen, it'll come out to a C. And on the next line, we'll have a BB as a ligature, followed by a kern, followed by a B. And then, but if we don't take the hyphen, we go A, kern A, BB, kern, BB. All right. Now, I think I did this right, but only the computer can really handle these kind of things. Well, in other words, the process of reconstructing after you found a hyphen can be a little complicated in the presence of ligatures, but it's important to do this because of words like difficult, and because we wanted to keep a general pattern of ligatures, to do ligatures properly, depending on what the user defines. Because I feel that now that ligatures are really the answer to accents in foreign languages, and the previous way TeX was doing accents turns off hyphenation, but also doesn't give the right keyboard patterns for somebody for whom accents is bread and butter. Now, if we have some text that involves multiple keystrokes to get accented letters, or even if we have some accented letters coming in as a pair of characters less than 128, which you could imagine doing, then all the hyphenation algorithms and so on will still work fine, because this ligature mechanism has been built in to be quite general. Something I see nodding her head here, and I just recall that in her Cyrillic font, plan for a Cyrillic font, one of the things for keyboarding is to type, I think, J1 for one kind of a soft stop, and J2 for a hard stop. This is the Russian symbols. I think they look something like that. I don't remember how to do them in script, but I don't remember exactly. But the keyboarders to type in those characters would type a J1 for one and a J2, and this recognized as a ligature, which converts into that. Now, you might say, how am I going to give patterns for such things? Because ones and twos in a pattern are supposed to mean numbers. Remember, if I said A, B, 4, D, that 4 isn't considered part of a ligature with B. Okay. Well, so what if I wanted to give a pattern that said if a J1 is followed by a J2, then I want a hyphen. Well, that's never going to happen, of course, in Cyrillic, but how would I give that pattern? And the answer is that you just put a 0 here, and a 0 there, and a 1 there, and if you see a 0, if it sees a 0, then it assumes a digit after it is like a letter. So there's this escape for giving the patterns that works. So the patterns can be described quite generally. At least I thought of that much. Now, so people in foreign languages will have a chance to get a program that'll generate patterns for them, and they can compare it against dictionaries. I think this is one of the more fun programs to play with different dictionaries, and to see what happens with them. Any questions on that? Yes?
Have you considered extending the program for spelling verification?
Yes. No, I haven't, but yes. And thesis discusses. It turned out that this packed trie structure is a extremely compact way to represent a spelling checker, and it's a good. And so it has two good uses, and probably the best method known for quick spelling checking. All right. Good comment. Yes.
Yeah, how do you handle apostrophes?
How do I handle what?
Apostrophes in words.
Apostrophes? Well, they could be put into hyphenation patterns if you wanted to, or else it would be the end of the word, and we would hyphenate only up to the apostrophe.
Okay, because I was thinking of something like French, where you have a lot of words that begin with L apostrophe followed by the word.
Right. Yeah. Good point. In fact, people from AMS, I just noticed this French place name. Do you know this one? Do I have that? The director of American Math Society is Levesque, and he capitalizes the V. And I just noticed here was a place where the E was capitalized. But these words, probably in French we would want to strip off the prefix like that, or else just put the words in the dictionary and make up the patterns on that assumption. See, in our English dictionary, we put in the words ending with S and ED. All those things are in this dictionary so that the patterns will be recognized without having to strip off suffixes. And so this probably is an analogous thing. As a prefix, a common prefix that would be put into words, and probably it'd be best to put that in as part of the patterns. Okay, thanks a lot. So tomorrow, the 4 sessions are specifically on system-dependent things, and if the man wants to ask me what I would recommend to read tonight, I would say, well, there's a couple of good movies on in town. But if you really want to read some of this, then I would go to the index, look up system dependencies. That refers you to about 30 or 40 modules. Look at those modules just to see what it says. Those are the modules, the entire set of modules that I think you might be especially interested to modify for your home system.